Hello everyone, welcome to my YouTube channel. Today we will solve Leetcode 75 problem. The problem name is sort colors, right? Let's read the problem statement. Given an array nums with an object colored red, white or blue, sort them in place so that objects of the same color are adjacent with the colors in the order red, white, blue. So there are three colored object is given and we have to sort them, right? We will use the integer 0 1 2 to represent color red, white and blue. So red is represented as 0, white is represented at 1, blue is represented at 2. What we have to do, we have to sort the array, first 0 then 1 then 2, right? See, they have given a array and we have to sort the array like this, and in place sorting, right? You must solve this problem without using any library sort function, right? So we know that there is already built-in sort function that is present in C++ Java programming language, but you cannot use to solve this problem using sort function, right? So you cannot apply this approach. What can be the other approach that's come to your mind? One approach that is coming in my mind is approach 1 is that what we can do, as only 3 elements are there, right? So we can create a frequency map, and we can create a frequency map. What is present in the frequency map? We will store elements and we will store the count of the element, right? We will traverse the array, and there is only 3 element, right? So no need of this. As there is 3 element, we know the 3 element 0 1 2. Now we will store how many times 0 is coming. So in this array 0 is coming 2 times, in this array 1 is coming 2 times, in this array 2 is coming 2 times, right? And then what we'll do, we will override the array by first we will override the array, we will override the original array. We'll first put 2 times 0, then we'll put 2 times 1, then we'll 2 times 2, right? So this is how you can solve this problem, right? First we will traverse the array, we will create a frequency map, we will store the count of all the elements that is present in the frequency map, and then we will again traverse the array and we will override the original array with the sorted part, right? So this can be the one approach. Now what is the time complexity of this approach? The time complexity is, we will traverse the array 2 times, the order of 2n, which is nothing but order of n. What is the space complexity? We are taking space, right? So here we are taking order of distinct element. So here distinct element is 3, so it is approximately order of 3, which is distinct element is 3, so it is order of 3, which is constant space, right? So we can apply order of 1, right? So this can be one approach. Now there is one very important approach, one important method that we have derived, and this is very important approach. Let's talk about the another approach 2. This approach is called Dutch national flag, because in Dutch national flag there are 3 colors, so that's why it is coming from that. So just like 3 colors, what we will do, we will use 3 pointers to solve this problem. 3 pointers to solve this problem. Let me write the array. Let us do the dry run. Let's say the array is 2 0 2 1 1 0, right? So there are 3 elements, so we'll take 3 pointer, right? So I pointer will be for 0, j pointer will be for 1, k pointer will be for 2. So 3 pointer 3 element, right? So I pointer will keep track of all the zeros that are there, j pointer will keep track of all the ones are there, k pointer will keep track of all twos are there. And we know that 0 represent the color, right? What 0 represent? Red, 1 represent white, and 2 represent blue. So here 0 represent red, white and blue, right? So let's do the dry run on this array. 2 0 2 1 1 0. Right, now as there are 3 pointer, now the next important thing is how can you initialize. Now the next thing that we need to keep, how can we initialize, right? So what will be the initial value or initialized value of all the 3 pointer? So let's say I is at 0, j is also at 0, k is n minus 1, n is number of element present in the array. So let me do indexing 0 1 2 3 4 5, right? So I is here, j is also here, and k is at the last position. Now in the what this approach says, we will traverse the array using j pointer, right? So j pointer will traverse the array, j pointer using j pointer, right? And when the j is traversing the array, what might be the possibility, what can be the possibility, right? So if there will be three cases. The array of j will be either 2, array of j will be either 0, or array of j will be either 1, right? Because there are 3 elements, so there will be 3 possibilities. Either array of j is 0 or 1 or 2, right? So when array of j is 0, what we will do? When array of j is 1, what we will do? When array of 2, then what we will do? What action we will do? That is what this Dutch natural flag algorithm says. So let's talk about that, right? So let's do the dry run, right? Let's do the complete dry run to get the better understanding. Let me again write the array 2 0 2 1 1 1 1 and final is 0, right? So I was here, j was here, right? So here array of j in when index is 0 0 1 2 3 4 5. So when j is 0, then array of j is 2. So array of j is 2. That means, see here we have represented 2 with k, right? So this 2 should ideally be present on the k side, right? And this is our k. So what we'll do, if this is the condition, if array of j is 0, array of j is 2, then what we'll do, we will swap array of j with array of k. We'll swap array of j with array of k, and then we will decrement k pointer, right? So we will swap j and k. So k will be 2 and j will be 0, and then what we'll do, we will decrement the k pointer to here. Now k is here, right? So this is the action that we'll take when array of j is 2. This is the action we'll take. We will swap array of j with array of k, right? Now again we will see, because we have changed our array of j value. Now what is happening? Now at j is equal to 0, what is there? At j is equal to 0, what is there? Array of j is 0. So if array of j is 0, then what we'll do, because 0, which pointer represents 0? It is I pointer represents 0, but we are encountering j, right? So when I pointer represents 0, then what we'll do, again we will swap array of j with array of I, right? We will swap array of j with array of I, and when we swap array of j with array of I, what we'll do, we will increment I and we'll also increment j, right? When this condition is met, then we will increment I as well as we will increment j. So let me do increment. We have swapped 0 with 0. Now nothing left. Now I is here, j is here. Now see, again j is 0. So if again j is 0, then we will again swap I with j. So we will swap I because they are at the same pointer, then swapping will again we will get 0 here, right? And after swapping we have to increment I, we have to increment j. So let me increment I as well as j. Now I is here, j is here. So when now at this position value of j is 2. So if value of j is 2, so what condition, what action we need to take? So here they have mentioned, if array of j is 2, then we will swap array of j with array of k. So we will swap these two element, here will be 1, here will be 2, and then we will decrement k. So k value will be here. Now k is here, right? This is how you are working, right? Now again the j value is change, j value is change, right? So now what is the updated j value? J value is 1, right? So we have seen what we'll do when array of j is 2, we have seen what we'll do when array of j is 0. Now we will see what we'll do because the first time array of j become 1, right? Because the first time array of j become 1. So what we'll do when j will become 1, let's see, let's write. So if this is the third condition, if array of j will be 1, right? And what one number represent, which pointer represent 1, which pointer represent 1, j pointer, right? So j pointer represent 1, then in that case what we will do, we will just increment j pointer, we will do nothing, we will do no swap, we will just increment j pointer, right? So when j is at index 2, we have encountered that array of j is equal to 1, right? This is the updated value. So in that case we will just increment j pointer. So now j pointer is incremented, I pointer is not incremented, only j pointer is incremented. Now j pointer is here. J pointer is here, right? So I and j both are here, right? Now what is j value? Array of j value is 1. So if array of j value is 1, then again which condition is satisfied? Array of j is value 1, this condition is satisfied. When array of j is value is equal to 1, this condition is satisfied. What this condition asks us to do? We just increment j pointer. So we will increment j pointer, and now j will be here, j is here. Now see, this j and k crosses, so we'll end our loop. So whenever j and k is crossed, we will end our loop, or we'll end our, see here j and k crosses each other, so we will end the loop, right? This is how you can solve this problem. If you want, then I can give you another example, right? But I hope you understood the problem. There are only 3 conditions that may arise, 3 possibilities. Array of j can be either 0, array of j can be either 1, array of j can be either 2, right? Because array of j is 0, then what we'll do, we will swap j and I, array of j and array of I. If array of j is 1, why we are swapping j with I? Because 0 element is represented by I, so that's why we are swapping. If array of j is 1, then we will just increment j pointer, we will do nothing. And we will when array of j is 0, we will swap array of j with array of I, we will increment I, we will increment j. If array of j is 1, we will just increment j pointer. If array of j is 2, then we will swap array of j with array of k, and we will decrement k pointer, right? That is the 3 things, that are the 3 possibilities, or that are the 3 action that we need to take in this Dutch nationalist flag algorithm. So let me write the code so that you can get clear understanding what I am saying. Okay, so let me write the code. So it is sort color, sort colors. What it is taking a array, right? It is taking an array. We will just sort the color. It is taking an array. Now the next thing is we will take 3 pointer, I which is initialized to 0, j which is initialized to 0, and k which is initialized to n minus 1, right? Where let me keep here only k, let me pass as parameter integer n, where n is the number of element, right? So this is how you can initialize all the 3 pointer. Now when we will stop, when is the stopping condition? While j is less than equal to k, or j is less than k, then we will stop, right? And what are the three conditions that may arise, that we will write. So if the first possibility is if array of j is equal to 0, so when array of j is equal to 0, then we will swap array of j and array of I. We will swap array of j and array of I. Then we will increment I, we will increment j. Else if array of j is 1, if array of j is 1, we will just increment j pointer, we will do nothing. And else if array of j is equal to 2, then in that case what we will do, we will swap array of j with array of k, right? We will swap array of j with array of k, and we will decrement k pointer, right? So this is how, these are the three conditions that may arises when we are traversing the j. First condition, second condition, and here third condition, right? So these are the three conditions that may come, right? And then what we'll do, we'll simply return the array, because now our array is sorted, right? Then we'll return array, because now the array that after modification, this array is sorted, right? So this is how you can sort the color, right? So now what is the time complexity to sort this entire color? Time complexity, we are traversing using 3 pointer, right? But the time complexity is we are traversing using 3 pointers, so worst case is order of n. Space complexity is also order of 1, we are not using any space, so space complexity is order of 1, right? So this is how we can solve this sort color problem. I hope you understood the solution. Thank you for listening.